All right, section 13.4, more solving equations. All we're doing in chapter 13, solving equations, solving equations, solving equations. So what I want to start by doing, instead of rewriting all of these in the helpful hexagon, which we can do another time, I want to go right to the problem. And I want to look at it and see if you can tell me what's different about it. Good. It's got cosine squared, and it's got a sine. So it's not a quadratic that's ready to go. The variables are not the same. Well, they're both theta, but you know what I mean. So what should we do? Any ideas? Nope. Interesting idea. Interesting idea. Someone said use two variables. The problem with using maybe two different variables is that I need two equations to solve it.
Well, it says substitution.
So if you read, I didn't want you to read right now. Yeah. If you read, something interesting is going to happen. So we're going to start with the most famous Pythagorean identity, right up here above this.
Equals tan squared.
No. Cos squared theta plus sine squared theta equals 1. Okay, that's the one we get from this top 7, remember? And we've done this once before, but now it's truly needed. How can I get just cosine squared equals? How do I get cosine squared alone? Exactly. Subtract over sine squared. So if I subtract over sine squared, it looks like 1 minus sine squared theta. And similarly, how would I get sine squared all alone? Subtract over cosine squared. 1 minus cosine squared theta. These are substitutions then. When we have cosine squared, I'm allowed to substitute in 1 minus sine squared. How convenient. It just happens to be the other trig function. So here we go. I'm going to substitute in right here. Why don't you circle cosine squared? And remember, the Pythagoreans are the squared functions. So don't sub anything else except the squared terms. So we're going to do 1. We're going to sub in 1 minus sine squared. The rest stays the same. Okay. I'm going to distribute. Next step. Anybody?
No, you can actually.
That'll be next. We're going to put our 4 and 5 together.
Ooh, I got one more.
1 second, Andrew. We got a positive 4 and a negative 5 gives us negative 1. Okay, and I think your step's going to come up next.
Yeah, that's what my step is.
The 4 and the 5?
Oh, no.
Haven't done it yet. Okay, what else now, Andrew?
Subtract actually combine the terms for the signs and you get 0.
Can't do that.
Oh, okay. I didn't
They're
see the square.
squared
Did not
and
see the square.
regular. I thought you were going to tell me about the signs in front.
Did not.
I don't really want a negative there. We can divide through by a negative 1. You don't have to show that word. Let's just change the sign of every term. So that's either multiplying through by a negative 1 or dividing through by a negative 1. Another way a teacher may describe it is you're bringing all the terms to the other side. So you would add 4 sine squared over, subtract 4 sine over, and add 1 over. So we have this now. Let's put those x's in. We'll put it in for sine theta. This one factors. It does. Do you remember how to tell something factors? Real quick. B squared minus 4ac.
Would you like?
Comes out to be a perfect square, right? Or a 0, or... You can always try it if you like. Let's put the factors down, since I'm telling you they're factor. 2x and 2x, 1 and 1, minus and minus. Split. It wasn't really x, it was really sine. Good, sine theta. We don't need to do both sides. They're going to produce the same answers.
30.
Ah, is that it, just 30? It is the reference angle, good. 30 is the reference angle. This number is, sign is positive in quadrants. 1 and 2. There's always 2 answers, unless it's quadrantal or whatever. I think I heard it. 150, good. And these are nice, clean answers. Remember, you could go back to the original problem, even though it was, it's not moving.
Not working.
You go back to the original problem, even though it was mixed, cosine squared and sine, and sub 30 in there and there, it should equal 0, and 150 there and there, it should equal 0. So this is a typical question, subbing in for cosine squared. And these two are a little different.
Are we gonna have
It's possible, Erin, like a question like we just did. It's possible. How about this one? It says number 8. What do you think you should do? Any, do you,
1 over.
so they're both great ideas. Which one's going to be easier?
Sine of cos.
Is this a situation where we need to go sine and cos, cos and sine? No, because we're going to solve for it. So I heard someone else say, Andrew said, how about we change cotan to 1 over tan? You got it. Good job.
Wait, so I actually just said something right for once? Did I actually say
You
something
say a
right?
lot of things right. I don't think we need to put the x in, but you tell me. I'm going to divide both sides by 3. Everybody still good there? Okay. And tan squared equals 1/3. Next step.
Sine divided by, no.
Nope, we're solving for tan. Okay, so you're way ahead of me. You square root of both sides, Justin? Okay. He's all the way to radical 3 over 3 already. Good. Very good. Except he forgot one little thing. Oh, beautiful. U square root, U plus minus. Good job. So what we have, let me just move up to this clean space. We have tan theta equals positive and negative square root of 3 over 3. We had a plus and minus 1 yesterday. Do you remember what we did? The signs of the number are both. Both.
These will be all 4 quadrants.
You got it. All 4 quadrants.
And
Reference angle for tan equaling radical 3 over 3. When in doubt,
30.
second tan, radical 3 over 3. 30 degrees. So we just have to rock around the clock with 30 degrees. 30 degrees in quadrant 1. You see how quiet you are? That's the easiest answer. 150. Good job. Good job and good job. There you go. Beautiful.
That's actually smart.
Last one. Do you see a similar strategy here?
Yeah, it should be 1 over sine.
Good job, Lauren. 2 sine theta plus 1 equals 1 over sine. And now, Erin, I want you to remember about cross multiplying. So you can do it. You got it. Good job. We would cross multiply. Bring that term over. Get a quadratic and go from there. Okay, homework again, page 537. 3 through 9 odd. That's only 4 problems. I'm also going to recommend you get your notebook in order. End of the year is coming up very quickly. I want neat, organized notebooks that you can study from. Any questions for the good of the order or otherwise?